You ever look at a weld and see that little rainbow halo spreading out from the bead? It looks like a desert sunset. But in the world of metal, that's actually the signature of a molecular soap opera happening just under the surface.
A soap opera? I usually just thought it meant I was moving too slow or had the voltage cranked up like I was trying to power a small city.
Well, you aren't wrong. But that sunset is the heat affected zone, the HAZ. It's the region that didn't actually melt, but it got hot enough to have a midlife crisis. The atoms started moving around, the grain structure shifted, and suddenly that steel isn't the same stuff you bought from the supplier.
So it's the uncanny valley of welding. Not quite liquid, no longer quite the original base metal. I've noticed on some of my practice plates that the metal right next to the weld snaps way before the weld itself does. Is that the has sabotaging me?
It's the heartbreak of the trade. You can lay down a bead that looks like a stack of dimes from heaven, but if you've cooked the surrounding metal into something as brittle as a saltine cracker, the whole joint is a ticking clock. I remember building a radiator core support for an old farm truck years ago. I was so proud of those welds. Deep penetration, beautiful crown. 2 weeks of bouncing over washboard dirt roads, and the metal literally unzipped right next to the weld. The weld survived fine. The steel next to it just gave up on life.
Okay, let's break the science down for the folks who aren't currently holding a piece of failed farm equipment. We have the fusion zone, the part that actually puddled, and then the has. What's actually changing in there?
Think of metal like a box of crystalline Legos. When we manufacture steel, those Legos are snapped together in a specific tight pattern. When you weld, the heat is high enough that the Legos near the fire start to vibrate and grow. We call it grain growth. Big grains generally mean soft or brittle metal. It's like the difference between a dense piece of fudge and a crumbly muffin. You want the fudge, the haze often gives you the muffin.
And depending on how fast it cools, you get different results, right? I remember you mentioned martensite once, and it sounded like a villain from a 1950s sci-fi movie.
Oh, martensite is the villain if you're not careful. If you're welding high carbon steel and you let it cool down too fast, like if you're working in a freezing shop and just walk away, the metal freezes into this incredibly hard, needle-like structure. It's hard as a file, but about as tough as a glass Christmas ornament. You hit it with a hammer, and it doesn't bend. It shatters.
So, basically, we're accidental alchemists. But instead of turning lead to gold, we're accidentally turning structural steel into glass. Neat. How do we stop that? Is it all about travel speed?
Travel speed is the big lever. There's a formula for heat input, volts times amps divided by how fast you're moving. If you're lingering like a teenager on a first date, you're dumping massive amounts of energy into that plate. The wider that rainbow discoloration, the bigger your danger zone.
What about the material itself? I've noticed aluminum behaves completely differently. It doesn't really give me the rainbow warning, it just gets angry.
Aluminum is a thermal sponge. It's so good at moving heat that the has can end up being massive. With heat-treatable aluminum alloys like 66-1, the factory did all this work to temper it to a specific strength. The second you touch it with a TIG arc, you're basically untempering it. You're taking it back to its softest state. That's why you'll see bike frames or racing parts get heat treated again after the welding is done. You're trying to reset the molecular clock.
That feels like a lot of pressure for a hobbyist. If I'm just building a workbench in my garage, do I really need to calculate my cooling rates and grain structures? Or is this mostly for guys building bridges and spaceships?
Well, if your workbench collapses because the legs turn to glass, your toes won't care if you aren't an aerospace engineer. But for most of us, it's about thermal management. It's why we do stitch welding, welding an inch here, then moving to the other side to weld an inch there. We're letting the heat dissipate so it doesn't pool up and cook the base metal.
I saw a guy on a forum the other day, dangerous place I know, suggesting that you should always preheat your steel with a torch before you start. Is that a pro tip or just a way to waste propane?
It's actually one of the smartest things you can do for thick sections. It sounds counterintuitive, adding heat to solve a heat problem, but if the whole piece is already at 300 degrees, the shock of the 10,000 degree arc isn't as localized. The cooling rate slows down because the surrounding metal isn't a heat sink trying to suck the life out of the weld. It prevents that martensite villain we talked about from showing up.
Speaking of heat sinks, let's talk about stainless steel. I've seen some exhaust pipes that look like they've been through a war. There's a term for that, right? Sensitization?
Yeah, and that's a nasty one. In stainless, if you keep it in a certain temperature range for too long, the chromium, the stuff that keeps it from rusting, decides to go on a date with the carbon. They form chromium carbides at the grain boundaries. Now you've got a stainless weld that's going to rust exactly where you welded it because the chromium isn't available to protect the surface anymore.
So the metal basically loses its immunity to the elements.
Exactly, you've compromised its superpower. That's why you see Taiji welders using those oversized gas lenses. They're trying to keep the weld and the has shielded with argon until they cool down past that danger zone.
That one looks different, hardly any discoloration at all. What's the secret sauce there?
This was done with a laser welder, but you can get close with TIG if you're surgical. Low heat, fast travel. It's like a bee sting versus a sunburn. A bee sting is intense but localized. A sunburn covers your whole back. You want the bee sting.
Okay, so if I'm at my bench today and I'm worried about my has, what are my red flags? What am I looking for that tells me I'm ruining my project?
Watch the puddle width relative to the heat tint. If the blue and purple bands are extending 2 inches away from a 1/4 inch weld, you're soaking it. Also look for undercut at the edges. If the base metal looks like it's being eaten away at the toes of the weld, that's a sign your heat is out of control and you're starting to lose structural thickness right where you need it most.
Does the welding process change the size of the has significantly? Like, is a MIG weld always going to have a bigger footprint than a TIG weld?
Generally, yes. Stick and flux core are the slow cookers of the welding world. They dump a lot of heat because they have to melt that flux. TIG is a precision scalpel. But honestly, the biggest factor is the meat servo holding the torch. I've seen guys with a MIG gun who move so fast and clean that the hayaz is barely there, and I've seen guys with a TIG torch who treat it like a campfire, just sitting there washing the puddle back and forth until the whole piece of metal is glowing orange.
Meat servo. I'm putting that on my resume. So if someone messes up, they've got a massive has, the metal is brittle, is it game over? Or can you fix it with post-weld heat treatment?
You can often save it, but it's a lot of work. You can normalize the steel by heating the whole thing up to a cherry red and letting it cool very slowly in a bed of sand or a specialized oven. It resets the Legos. But for most of us, that's not practical. The best fix is usually just cutting it out and starting over with a cooler head and a faster hand.
I think that's the hardest part for beginners. You want to go slow because you're nervous and you want to see what you're doing, but the slower you go, the more you're sabotaging the very thing you're trying to build.
It's a paradox. You have to be confident enough to move faster than your brain wants to. I usually tell people to practice on coupons, just scrap pieces, and purposefully try to melt through them. Find where the too much heat line is, then back off 10%.
And maybe don't start by welding the suspension on your race car.
Definitely not. Start with a garden gate. If the has fails there, the only victim is your pride and maybe a confused dog.
Truth. So, to wrap this up for the folks in the shop, small has good, big has bad. Move fast, stay consistent, and if it starts looking like a rainbow, maybe take a breath and let the metal cool down.
And remember, the metal is alive. It's shifting and changing under your hands. Respect the heat and it'll hold. Abuse the heat and it'll break your heart and your projects.
Wise words from the man who once unzipped a truck.
Hey, I paid for that lesson in sweat and tow bills. No need for everyone else to do the same.
Next time, we're talking about why my wood glue joints are stronger than the wood itself, right? Or is that another science soap opera?
Oh, that's a whole different drama. We'll get into it. But for now, let's go see if we can weld something without creating a sunset.